So guys, this is the last part in this chapter. This is the last one. I'm gonna do it. I forgot to take the pencil. Just 1 minute. Okay, this is the last part. It's called 7. We have the midpoint theorem in a triangle. Oh, the midsegment. And we also have the midsegment and a trapezoid. So let's start the midpoint theorem in a triangle. Okay, if I have here a triangle, I have CAB is a triangle. D is, so what is the given? It's very important to know what is the given. The given is D midpoint of CA, E midpoint of BC, okay? So what it gives me as a result? So be careful. I have two givens, and the two givens are the two midpoints. So I have D midpoint of AC and I have E midpoint of BC. Two midpoints will give me what as a result? Will give me that DE and AB are parallel, and it gives me that DE is equal to half of AB. It means if DE is 4, AB will be 8. If AB is 6, DE will be 3. So be careful. We can call DE the midsegment in a triangle, or it's the midpoint theorem, as you like. So the given are two midpoints. It will give me parallel plus equal to half of it. I think you know this from last year. Okay, let's go now to the inverse of the midpoint theorem. Inverse of the midpoint theorem. Now, if the given is what? One midpoint and one parallel. So if D is midpoint, I don't know what is E. And if I do from D the parallel to AB, so the given is one midpoint and one parallel. What will give me as a result? It will give me another midpoint. So DE will cut CB in its midpoint. So E will be the midpoint. And sure, it will give me also that DE is equal to half of AB. So be careful, guys. I will summarize. What is the midpoint theorem in a triangle or the midsegment? The theorem is I have two midpoints. If I have two midpoints, so I go back a little bit. So two midpoints, the given is two midpoints, will give me parallel plus equal to half of the big base. Okay? Listen, I can take the midpoint of this side plus this one, and this one will be parallel to this one. So now I gave you here one example. The inverse is what? The given is one midpoint and one parallel. It will give me another midpoint and equal also to half of it. Okay, so the inverse is one midpoint plus a parallel. So E is midpoint of AC and DE parallel to AB. So I'm sure that DE will cut CB in its midpoint. So as a result, I will have the midpoint E, and sure, the equal to half of it, I still have it. DE equal to half of AB. Now, 8, this is the last part in this chapter, and this is the last thing that I've seen in this chapter. Definition of a trapezoid. What does it mean, trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. When I say one pair of parallel sides, it means just two sides are parallel the base. So those two parallel are called the base. The parallel sides are the bases. A trapezoid has two pairs of base angles. Those are called here the base angles. See it? And the non-parallel sides are called legs. Okay? So if those legs are equal, it will be a isosceles trapezoid. Okay? But any trapezoid has two parallel sides, just the bases. The legs are not equal. But once the legs are equal, I can say that this trapezoid is an isosceles trapezoid. Is it clear? Yeah, this is the remark. If the legs of a trapezoid are congruent, it means are equal, then the trapezoid is an isosceles trapezoid. So if I have those two legs equal, I can say that this is an isosceles trapezoid. So first you need to know what does mean trapezoid. I have two parallel sides and the legs are not equal and are not parallel. But once the legs are equal, I can call it isosceles trapezoid. Let's go now to the midline theorem and the trapezoid. It's similar to the midline or the midsegment and a triangle. The midline of a trapezoid is the segment that connects the midpoint of its legs. Yeah. If I have, this is a trapezoid ABCD. If I take the midpoint of AB and the midpoint of DC and I join it, this segment is called the midsegment. This segment is called the midsegment. Okay, and the theorem of it, it's similar as the midpoint theorem for the triangle. What does it mean? Let's see what does it mean. So this midline or this midsegment is parallel to the other bases. Like in the triangle, it's parallel to the base. So the midline of a trapezoid is parallel to each base, and its length is 1/2 of the sum of the length of the bases. This sentence, I have it here as an equation. So I have MN parallel to BC and MN parallel to AD. And what will be MN is equal to BC plus AD over 2. This is the rule of the midsegment or the midline in a trapezoid. It's easy, it's very easy. Just you need to take notes and review it. And that's it. We don't have anything else. Okay? Is it clear? I want to write a small remark. Perhaps you didn't see it before. Okay, what is the area of a trapezoid? I want to write it. Area is equal. I hope that you can see it. This is called base 1, and this is called base 2. And you can do from B height. This is called the height. Okay, H. The area is base 1 plus base 2. Okay, all of it times height over 2. Perhaps I will ask you about the area and a trapezoid. Okay, so write it as a remark. So I will repeat. In this figure that I have here, my bases I have BC plus AD, BC plus AD. I don't have the measurement again. I write just the formula. Okay, times the height. I can give you the measure of the height. It will be given over 2. This is the area of a trapezoid. I will wait a little bit to be sure that you can see the writing. I'll go back shway, and then I will go back to this page. I want to be sure that you're gonna see the writing, because sometimes my writing is a little bit late. So I will move to the back shway. Then here, so I have it here. So the area of a trapezoid is small base plus big base times, this is multiplication over 2. Yani here in my figure, BC plus AD times the height H. The height, and you do the perpendicular from one vertex to the other side. This is the height of the trapezoid over 2. That's it. This is all our chapter, and we're done from the first part. We still have just one worksheet linked to this, and we're going to do an assessment.